Hello. Hi, humans on the internet. I hope you're all staying safe and healthy in these crazy times. Thank you so much for joining us here today. And welcome to the Internet Measurement Village, or shall I say the online Internet Measurement Village. Starting from today, we will be live streaming 17 presentations covering a wide range of projects from the Internet measurement world. These projects will be discussing how they go about measuring internet censorship, internet outages. We'll also include presentations from local censorship measurement projects in countries that include Venezuela and Ukraine, among several others. We will also include circumvention tool projects so that you can learn how to circumvent internet censorship. And we will have some presentations from human rights advocates discussing how they are fighting against internet shutdowns in defense of a free and open internet. So we have a very exciting presentation ahead of us. It's going to be live streamed almost every day, starting from today until the 3rd of July. If you haven't already, please check out the schedule. The link is included in the slide. And don't forget to mark your calendars. As you can see, we're going to be joined by many great projects and great organizations. So I think this is going to be very exciting. And I guess as a final note on this, originally the Internet Measurement Village was meant to be a 2-day event as part of the Internet Freedom Festival. But as the Internet Freedom Festival was unfortunately canceled in light of the COVID-19 pandemic, we decided to bring a version of the village online. So while it is a little bit different in comparison to what we had initially envisioned, we still hope that you will find it interesting and useful and that you will join us and bring your questions. As we're going to try to make it as interactive as possible. Even though there will be presentations that will be live streamed, there will be a live chat through which you will be able to ask the presenters questions towards the end of each presentation. I'm excited to have you here, and please join us as well over the next weeks. I guess we can start off with the presentation that I think you came here for, which is measuring internet censorship with OONI. First of all, hi, my name is Maria. I work with OONI. OONI is an acronym for the Open Observatory of Network Interference, and we are a free software project, and we have been measuring internet censorship around the world since 2011. Our goal by building software is to enable anyone around the world to measure their networks, to detect whether websites and apps are blocked, and to collect network measurement data that can potentially be useful for research purposes, but also to support advocacy efforts around the world. So before I get into the details, what do we even mean by internet censorship? What does it even look like? So this is an example of internet censorship in my country, Greece. In Greece, gambling is illegal, as in many other countries. And so when you try to access gambling websites, instead of viewing the actual website, you instead see something that looks like this. This page essentially informs internet users that they are not allowed to access the intended website because gambling is illegal, and they reference the relevant law. In other countries, you also have block pages. This is quite a common censorship technique around the world. This is an example of a block page in Iran, where you can very clearly see that access to the intended website is prohibited. Unlike Greece, though, in countries like Iran and in other places, censorship expands beyond gambling to also include human rights websites, media websites. In the case of Iran, we have found block pages like this being served for women rights websites and a variety of different Kurdish websites as well. This is another example of a block page. This is from Indonesia. What you can see, I guess the thing that is you have in common from all the different block pages is that it's quite clear that you're not supposed to access the website you are trying to access. In some cases, they even include cute animations, like this one here in the Indonesian block page. And more importantly, in several cases, like in this one, they also inform you why it is blocked, and they tell you, for example, that this is in compliance with certain laws and regulations. But in other cases, internet, and actually probably in most cases, internet censorship is not so obvious. this is an example of trying to access a website in Cuba where instead of having some sort of notification that informs you that access to the intended website is blocked, instead you just see a blank page like this one. Or maybe in other cases, you would see some sort of error message. There are many cases of censorship where to the average internet user, it may not be clear if access is intentionally being blocked, and if so, why. It may look like something is blocked, but maybe it is inaccessible due to a number of reasons, such as the website being hosted on an unreliable server, due to transient network failures. There's a variety of different types of reasons why something may be inaccessible. But we don't have transparency as to whether it is in fact intentionally being blocked by your local internet service provider in every case. Which brings us to the question, why measure internet censorship? So for starters, as I just said, many cases of internet censorship are quite subtle. Unless they serve a block page, like the cases that you saw before, most other censorship techniques are quite subtle. The mechanisms that ISPs will adopt in order to block access will be such where it will not be easy to necessarily tell as an average internet user if you're not able to access a specific app or website because it is blocked or because due to other reasons. And this is particularly concerning because again, like there's so many different types of reasons why a website may be inaccessible, which may actually have nothing to do with government commission censorship. So for example, again, as mentioned, it could be the case that a specific website actually is blocking access to IP addresses originating from a specific country, which is a case of server-side blocking. It could be the case that you are trying to connect to a service from an unreliable network. There's so many different reasons as to why why an internet service may be inaccessible. So the only real way really that we can evaluate if the internet provider is intentionally blocking access is by inspecting the network and trying to understand why, from a technical perspective, why it is that we cannot access the intended resource. Furthermore, it may be the case that maybe you come from a country where you don't often come across cases of internet censorship, and maybe you think that, oh, this is just a problem for countries like China or Iran or countries where you often hear of cases of censorship. But the reality is that censorship can differ over time, especially since a lot of cases of censorship can be politically motivated. But also, internet censorship, as we have seen, can vary from network to network, even within a country. So maybe you are not experiencing internet censorship on the specific network you're using, but maybe other users on other networks are. So in order to be able to evaluate whether access to services has been obstructed on a nationwide level, in theory, we would have to measure every network in that country in order to be able to have more insight on the matter. And on this point, actually, there can be various cases which can go unnoticed. In some cases, governments may be transparent about internet censorship, and maybe they even publish an official block list, which is a list of websites that they instruct internet service providers to block access to. In other cases, and probably in most other cases, governments are less transparent about censorship orders. And this lack of transparency often also translates to how the blocking is implemented. And this is why, for example, there can be cases of what we call overblocking, where access to a website or an app may continue to be blocked, even though maybe legally they're not required to. There's an example of this that we actually saw in Indonesia, where video and Reddit were blocked. But then there was a court order which ordered ISPs to lift the block. Yet, through measurements, we were able to see that they continue to be blocked on some networks 2 years after the court order had instructed the block to be lifted. I don't think the ISPs in that case necessarily had ill intent or anything, but I guess this is just to say that there is the need for oversight. There is the need to be able to ensure that if internet censorship is to be implemented, there is some sort of justification for it, and that when there are orders for a specific service to be unblocked, that ISPs actually do follow through. There can also be cases of collateral damage that can go missed. Cases of collateral damage are, for example, when a range of other internet services beyond the ones that they're intending to block also get blocked. An example of this was in Egypt, actually, where several years ago, ISPs were ordered to block access to the New Arab, which is a media website. But in doing so, they ended up also blocking access to hundreds of other websites that were hosted on the same CDN, even though they were not, intended to block access to those other websites. This was an example of collateral damage. And a lot of these cases can go really unnoticed unless you're actively measuring networks to see what is happening. And lastly, and I think for me this is an important point, that it can be quite easy to notice when popular apps and websites get blocked. So for example, if WhatsApp gets blocked or Facebook gets blocked or some other service that lots of people use, you're very likely to notice. But when less popular sites get blocked, such as the websites of minority groups or other marginalized communities, their blocking can often go unnoticed. And so in these cases, we observe that some of the same forms of oppression that exist in the offline world are translated on the online world. And often, there's very little public debate because they simply go unnoticed. So through network measurements, we want to, enable the public to detect these cases and bring them to light, essentially. And that was sort of the idea behind OONI, the Open Observatory of Network Interference. The project started back in 2011, and at the time, there were other great projects that were already examining internet censorship and performing network measurements, such as the OpenNet Initiative, which is a really fantastic project, and I also still continue to go back to it and refer to it as part of my research. However, at the time, there really wasn't a project that did this sort of research with open methodologies and free and open software and open data. There wasn't really a way that researchers could independently verify cases of internet censorship. And being able to independently verify them is extremely important, because detecting internet censorship and distinguishing it from what could be a case of DNS misconfiguration, or from what could be a transit network failure, or one of the many other reasons why a service may be inaccessible, can actually be pretty challenging. And in order to be able to do this effectively and to be able to ensure that our findings are accurate, we feel that the only way to really do that is with open methodologies that can be peer-reviewed by the broader community. And then there is also the aspect that, as mentioned, internet censorship can and does vary often from network to network within countries. So how can we be in a position to monitor internet censorship across thousands, across millions of networks all around the world that make up the internet? How can we know what the health of the internet looks like if we're not actively monitoring and measuring every single network on the internet? So what OONI thought was that one way to try to do this is basically to enable the public to do all the measurements, to enable everyone around the world to measure all the networks so that we can then see what is happening from a sensor perspective. But then there's a question of, okay, if someone in Greece or in China or somewhere else is performing tests, how do we gain access to their results? So in designing its software ecosystem, OONI has developed not only software like a client that anyone can run in order to perform experiments and measure networks and measure internet censorship, but it has also designed a system by which it collects all the measurements, all the test results from all the users around the world by default and openly publishes them. And in doing so, we hope to increase transparency of internet censorship around the world and enable the public to be able to monitor on an ongoing basis when and where and how internet censorship has been implemented. And as an end result, we aim to support public debate around information controls. And this part about public debate, I think, is very important because censorship, is often politically motivated, but censorship is also the byproduct of a country's legal system, a byproduct of its social and cultural system. And so it obviously varies significantly from country to country. And what may be considered okay to access today may be less acceptable in the future and vice versa. So it is very important, we feel, that there is this ongoing public debate around these issues. But in order to have this debate, we first need to have transparency around what is blocked. And that is why since 2012, OONI has been building open methodologies and open frameworks to enable the general public to measure internet censorship. And since 2012, millions of network measurements have been collected from more than 200 countries, all of which have been openly published. And every day we continue to collect and process and openly publish thousands of measurements from around the world. So how can you participate? We have built this, OONI Probe is our software, is our tool, our client that you can, that is free. You can download it and install it for free, and it's based on free and open source software. All of our code is in our GitHub repository, which is github.com/OONI. OONI Probe is available for both mobile and desktop. On mobile, you can get it on Android, F-Droid, and iOS. On desktop, we recently launched a new app for Windows and macOS as well. If you're on Linux, you may be interested in our experimental build, which is available in our Probe desktop GitHub repository, or you can try running the OONI Probe CLI, the command line interface, which is also available through the OONI through our install page on our website, if you see the link. And we're also working on building official packages for Linux. But since most people are on Windows and Android, those are the primary platforms we're supporting at the moment. So what does the OONI Probe app have and what does it do? The OONI Probe app essentially consists of a variety of different tests that enable you to examine different properties of your network. Over the years, since 2011, my colleagues have developed numerous network measurement tests, which if you're curious, you can check out again in our GitHub repository. But the ones that are shipped as part of our apps, and if we were to group them, cluster them in categories, what you see are the main categories of our tests. One of our main tests is that of measuring the blocking of websites. And then we also have tests for measuring the blocking of instant messaging apps, specifically for measuring the blocking of WhatsApp, Facebook Messenger, and Telegram. And the reason why we selected those apps is because they're amongst the most popular and commonly used apps around the world, but also, unfortunately, they're frequently blocked as well. And then we also have, and then once you've measured the blocking of websites and instant messaging apps, then there's a question, do censorship circumvention tools work? Am I able to circumvent the censorship on this network through the use of a VPN like Siphon or through the use of an anonymity tool like Tor? And that is why we have also built circumvention tool tests, which have recently been shipped as part of the desktop app, one for Tor, and one that measures Tor, another one that measures Siphon. And if you're interested in learning details about how each of these tests work, I've provided a link there which provides test descriptions for each OONI Probe test, and it also links to the respective specification for each test as well. In addition to these tests, we also have network performance tests, NDT and Dash. NDT is a speed test. Dash is a test for measuring video streaming performance. Both tests were developed in collaboration with MLab, who will also be doing a presentation as part of the Internet Measurement Village. I believe their presentation is on the 15th of June, if I'm not mistaken. I definitely recommend checking that out to learn more about network performance. And as part of this test, we also include what we call middle box tests, which essentially are tests designed to examine whether specific network appliances are used on your network. Now, these middle box tests, they're commonly used by many ISPs around the world, often to, improve network performance or to enable you to have faster access to websites and services. But sometimes these sorts of network appliances are also used to implement surveillance and or internet censorship. And this is the angle that we're particularly interested in, which also sort of what motivated us to develop these tests. But essentially, by running these tests, you can examine whether there's the presence of a middle box in your network and whether there are signs of potential network tampering. So out of all of these tests, I don't have time to get into the details of every single test, unfortunately, but I do want to draw your attention to the web connectivity test, which is the OONI probe test designed to measure the blocking of websites. Now, how this test works is that essentially, I just realized that the slide, oh well, sorry about that. How the test works is that essentially it attempts to perform three main sorts of checks, and it tries to perform these checks over two networks at the same time. The one network is your network, the local network of the user, and that is the network that is potentially censored, because that is what we're investigating. The second network is what we call the control network, which is the non-censored network. The network where we control the upstream, and so we know that no internet censorship has been implemented. And so you will perform three checks. The first one is DNS lookup, where essentially you're trying to see which IP addresses are allocated or mapped to the specific websites that you are testing. Then you try to perform a TCP connection to connect to the IPs that have been resolved for those websites, and you try to do an HTTP GET request. If you're able to successfully perform these three steps over both vantage points, and the results are automatically compared, then we say, okay, everything is good. There's no sign of internet censorship. These tested websites appear to be accessible. If, however, the results from your network in comparison to the results from the control network vary, then that is flagged as an anomaly, which means, something is wrong. It may be the case that this tested website is blocked. Now, depending on which check fails, that indicates what type of anomaly we have. For example, if the DNS lookup fails, like if it doesn't resolve to the same IP address in both cases, then we say, this may be a sign of DNS tampering. Or if the TCP connection is not successful, then we can say that, it's a sign of TCP IP anomaly, and so on. So that signals the first indication of what type of anomaly we're referring to. And then we dig in deeper to see exactly what has happened, and to determine whether it is an actual case of censorship or if it is a false positive. Unfortunately, false positives do occur due to a number of reasons, and we analyze this in detail in the frequently asked questions section of our website. But essentially, treats anomalous measurements, as a sign of potential censorship, and dig into the measurement data to confirm further. So when you run this test, the question is, which websites are you actually testing? So obviously we are not in a position to test every single website on the internet as much as we would love to. That is not possible, practically speaking. And so we have to sort of curate. We have to serve the probes a certain list of websites to test. To this end, the Citizen Lab, which if you're not familiar with them, they're an excellent research project based out of the University of Toronto. They have been hosting since 2014 a GitHub repository called test lists, which essentially includes lists of URLs that are measured by OONI probe, but also by other censorship measurement projects that you will learn about during the Internet Measurement Village. There are two types of test lists. On the one hand, there is the global test list that includes internationally relevant websites. So that will include websites such as Facebook.com, BBC, and other sites that are somewhat relevant globally speaking. And then there are the country-specific test lists, which only include websites that are relevant to a specific country. Now, we try to make these test lists as diverse as possible, which is why we have 30 different categories under which the URLs fall under, and we try to include as many websites from these categories in these lists. I guess one thing to highlight here is that a test list differs from a block list. On the one hand, a block list, which I mentioned earlier, is, for example, a list of websites that a government shares and basically instructs internet service providers to block access to those specific websites. Whereas a test list is not meant to only have websites that are blocked. It is, I mean, sure, it's great if it does have also websites that are blocked so that we can collect relevant measurements, but it also has a wide range of other websites that may not necessarily actually be blocked right now, but are interesting to test nonetheless. Because that's another aspect that I should highlight, that we don't only want to confirm censorship, we also want to discover internet censorship. And because we assume that tests are run on a daily basis over a long period of time, we keep monitoring the accessibility of certain websites, and then if and when they do get blocked, we'll hopefully be able to capture relevant measurement data that can be useful as evidence. And in the end of the day, you can only really, say something conclusive about a site once it's blocked, if you've been testing it before, and you can say that, all these previous months or years, it was always accessible. Now, in this moment in time, we see that it's blocked. And hey, this moment in time, it also happens to be a protest or some other event which could potentially be correlated to the blocking event. So because, so as you can imagine, the quality of OONI probe measurements greatly depend on the quality of these test lists. And what I mean by this is that if, for example, there are websites in your country that are blocked but are not included in this test list, they will not get tested. And then if they don't get tested, there won't be relevant data available. So ensuring that these test lists are up to date and that they include relevant and interesting websites that are likely to get blocked, whether now or in the future, or where if they did get blocked, it would actually be, a big problem. That is very important to update them. But obviously, I'm not in a position to know which websites are interesting or relevant to test in your country. You are probably the expert or know better for your own country. And that is why these test lists are openly available on GitHub in order to encourage community contributions. If you are interested in reviewing the test list of your country, and we definitely encourage you to do so, please check out our guide. I include here a link which provides all relevant information and step-by-step instructions on how you can go about updating the tests of your country. But if you're not a GitHub user and you would still like to contribute, please feel encouraged to email me personally or email our team, and we're happy to help. I guess what I'm trying to say is don't let GitHub stop you. Please feel encouraged to contribute. And on this note, and if you're interested in learning more about test lists, which I think is a fascinating topic, I definitely encourage you to go to watch the presentation tomorrow, the test list presentation tomorrow. It's at 3 p.m. UTC, live stream here on the OONI channel again. It will be facilitated by Igor, who works with Netalitica, and he works with researchers around the world on updating these test lists. So I definitely recommend that you go to that session and learn all about test lists there. So when you run the OONI Probe app, as I mentioned, it includes many different types of tests. And depending on the test that you run, you get different results. From the screenshot, what you can see is some examples of the types of results that you can find inside the app. On the one hand, you get an overview of what are the types of results on a high level. So you can see, for example, that certain tests were run, for example, a certain number of websites were tested. Out of the 20 tested websites, 3 were blocked, the rest were accessible, etc. But then if you tap on each one there in the app, you can then drill down into each separate measurement. And by measurement, we mean the separate result from each test, where on the beginning, you have a sort of high-level overview of the test results. For example, here you see that piratebay.org was tested. On a high level, we're telling you that it appears to be blocked by means of HTTP blocking. If you want to access the raw measurement data to confirm whether it in fact appears to be blocked, then you can tap on the menu icon on the top right corner in that measurement page and access the raw measurement data. Similarly, as you can see in the image next to it, you can get the data for other tests like the speed test and so on. And then the UniProbe desktop app was recently launched, and then as part of that, I guess it has two features that we're very excited about. The first one is that I think the desktop app is best suited for more comprehensive website testing. That is to say that because on mobile, users obviously have bandwidth constraints, or at least more so definitely than on desktop usually. The way that UniProbe works on mobile is that when you tap run on the website card, instead of testing all of the websites that are in the test list that were mentioned, you will instead test a random selection of websites and as many as you can connect to within 90 seconds. And then every time you tap run, you will test a different batch of websites from those lists. And we do this so that we can avoid eating up all the data of our beloved community. However, if you are connected to Wi-Fi or you don't have social constraints and you would like to do more comprehensive testing, you can also do that on mobile. You can go into the settings and then disable the limit to the test duration. But on desktop, it is sort of best suited for testing everything at once. So when you click the run button on the websites card, you will test all of the websites in one go. Another thing that I find particularly exciting about the desktop app is that we included in it our new Tor and Siphon tests, which are not currently available in the UniProbe mobile app, but will be shipped there very soon as well. So in the meanwhile, I definitely recommend installing the desktop app and trying out the new Tor and Siphon tests. As a heads up, and I think this is a very important thing to highlight, UniProbe is not a privacy tool, which essentially means that depending on your threat model, depending on the environment that you're running UniProbe in, it can potentially be risky for you. There are obviously many different factors that need to be taken into account. Again, such as your threat model, the laws and regulations of your country, what exactly it is that you're testing, etc. Like, obviously, it's hard to say what applies in every single scenario. But I think some main things to be aware of is, first of all, that UniProbe is not a privacy tool, which means that anyone who is actively monitoring your internet activity, such as your government or your local internet service provider, they will know that you're running UniProbe. The fact that you're running UniProbe is not hidden. And we definitely don't recommend running UniProbe over VPN, because if you do that, you will be testing the network of the VPN. You will not be testing your local network, which is the point. So, yeah, so I think we have been taking various measures in order to make UniProbe less fingerprintable. But I guess this is just to say that, this is something you should have in mind and evaluate depending on your threat model. Another thing to keep in mind is that the default list of websites that you will test, if you just tap run, may include provocative or objectionable or illegal websites in some countries. And what we mean by this is that, as I mentioned, the lists include a broad, wide range of websites, and they will include, for example, pornography, they'll include gambling websites, they'll include websites that maybe testing them in some countries is absolutely fine and it's no big deal, but maybe testing them in a different country where maybe that content is illegal, maybe, by doing that, that will raise a sort of red flag. So that's something to keep in mind about, the sort of default website testing. Another thing to keep in mind is that, again, by default, all UniProbe test results are openly published. And the reason why we do this is because our goal is essentially to increase transparency of internet censorship and to enable the general public to learn from the measurements and to use the measurements as part of their research and advocacy efforts. So that means that your test results will be published. However, maybe, in some cases, this may not be optimal for your threat model. The way that UniProbe has been, although UniProbe is not a privacy tool, because from the very beginning it has been a community project since the very beginning, it has been designed with user privacy, user safety in mind, even though it's not a privacy tool per se. Which means that, for example, our principles that govern our data practices, all have user safety in mind, and you can learn all about them through our data policy, which is linked here in the slide. And so while we do, and that is why, for example, we do not actively collect your IP address, although if you do want to share it in order to make the measurements more reliable, you do have the option to do it, but it's not the default. So yeah, I guess what I'm trying to say is that I think you need to evaluate whether OONI probe is the right tool for you, and to keep in mind that in the end of the day, it is an investigatory tool for increasing transparency of internet censorship. That said, there are no cases that we are aware of where anyone has gone to trouble as a result of using OONI probe, but it's important to keep in mind of the potential risks, and if you don't feel comfortable, seek legal advice from your local lawyers. And we share relevant documentation here about the risks, which has more details. To help reduce the risk, what we try to do from our end as well is to provide users with as much choice as possible. So on the one hand, one thing you can do is actually contribute to the test list, to the list of websites that are tested by OONI probe, and that way you can influence which websites are tested. And if there are websites that you don't feel comfortable with, you can propose to have them removed. And another thing that is, and obviously the different types of OONI probe tests include different weights in terms of potential risk. So for example, maybe some users prefer to only run the speed test or only the performance test, and not run web connectivity and test potentially controversial websites. So my point is, you can configure your OONI probe use and run the test that you feel comfortable with. But more importantly, in our apps, we provide settings that enable you to choose what type of data, if any, you want to upload to OONI servers, depending on what you feel comfortable with. And here, for example, we provide you the option, for example, to opt out from sending us your ASN, which is your network information. You can opt out from sending different types of data, but also, more importantly, you have the option to opt out from sending us any measurements at all. So if you want to use OONI probe because you're curious to measure your network, but you don't want to have your results published because you don't feel comfortable with that and you're in a high-risk environment, you do have the option to opt out entirely from sending us measurements. So please make choices depending on what you feel comfortable with and depending on the environment you're running OONI probe in. Regarding websites, you can also choose which websites to test. So if you want to circumvent the default websites that are tested as part of the test list, inside the mobile app, if you tap on the website's card, you will see that there is a Choose Websites button. By tapping on the Choose Websites button, you can literally test any website that you want. You just type in the website, you tap Run, and you test that website on the spot. That way you can limit your testing to the websites that you feel comfortable testing. Another option that you have through the settings is to enable which categories of websites to test. So as mentioned, the Citizen Lab test list, they include URLs that fall under 30 broad categories. Now, these categories are displayed in the settings of the app, and you can enable or disable the categories that you want to test depending on what you feel is safe for you or based on your research interests, or for example, if you're doing research and you only care to test media, you can, in theory, disable all the categories and only leave media enabled. So you have choices you can make here as well. And you can also choose which websites to test through OONI Run. And actually, this is probably preferable if you want to test a long list of websites, which may otherwise be quite tedious to manually type one by one inside the mobile app. Through OONI Run, essentially you can, if you have, for example, a long list of websites, you can copy-paste that list here into the URL slots, and then click Generate, and you will generate a mobile deep link, as you will see in the next slide. This link is not like a website. It is basically a link that encodes the OONI probe software. It is meant to be used with the OONI probe mobile app, and it includes the websites that you just added. And the purpose of this link is to enable you and communities around the world to coordinate OONI probe testing. So practically, let's imagine that right now there are, protests, and people on the ground are reporting that specific websites are blocked. They're reporting that Facebook is inaccessible, they can't access facebook.com, and they can't access several other websites. You can add those websites, generate the link, share the link with them, and then, assuming they have the OONI Probe mobile app installed, all they need to do is tap on the link. They will see which websites you want them to test. They just tap run, and it runs, and they test those websites. And this can be a very powerful tool for coordinating immediate rapid response testing during protests, during elections, and during other events. It can also be useful for research. For example, if you want to collect measurements from many different regions in a country, or many different countries, or many different networks within a country, all you need to do is share these links with other OONI Probe users in those countries, regions, networks, and they will run the tests. And then all the results will be automatically published. As you can see through this pop-up window, you also generate widget code that you can use to embed as a button. And here I share with you an example of some buttons that are embedded in the OONI in our own website. So essentially, to enable the more targeted testing of specific thematic websites, such as social media, because social media is often blocked during political events, we have created this button so that you can go there and you can easily test the most popular social media websites by just tapping on the button and opening it with your OONI Probe mobile app. Likewise, we have embedded various other thematic buttons, including media websites, VPNs, human rights websites, LGBTQI websites, COVID-19 related websites, and so on. So you can customize this, and depending on your research or your advocacy, you can coordinate customized testing, thematic testing, and run a campaign. We have plans to improve OONI Run, and we recently carried out an OONI Run usability study. If you're interested in learning about all the feedback that the community shared and what are our plans for next steps, I encourage you to go to our website and find the report published under our blog section. So I see that I'm running a bit late in time, sorry about that. So all of these measurements, as soon as everybody runs these tests, all the measurements are openly published. We openly publish them in essentially two places. The one is OONI Explorer, and the other one is the OONI API. Now, OONI Explorer is a web interface designed for human rights activists, journalists, social scientists, and the general public, so that you can have an interface to interact with and search through the various measurements on a country level. You can search the measurements and get an overview of the stats on a country level, but you can also use our search tool to dig through them in detail. Now, before getting into the measurements, one thing that is important to highlight is how to actually look at the measurements and how to interpret the measurements. So generally speaking, our measurements can fall under, say, three categories. The one is that is normal, in which case we say that the tested website or the tested app is accessible and everything seems to be okay. It means that all the checks of the specific test worked as expected, and so we do not see any sign of network interference. An anomaly, as mentioned before, is the case where the test does not perform as we expected it to work, and so it is sort of flagged that, like, uh-oh, something's wrong, it may be blocked. Anomalous measurements might contain evidence of censorship, which we think may be most of the cases, but not necessarily, because there may be cases where there are false positive. So sort of treat an anomalous measurement as a red flag that, something is wrong, need to investigate further, need to dig into the measurements to examine what's happening. When it comes to website testing, we're able to automatically confirm cases when block pages are served. So before I mentioned block pages, but in case you've forgotten, this is what a block page looks like. This is an example from Indonesia. So in this case, there is no ambiguity of whether it's blocked or not. They're even telling us, hey, this is blocked. We know this for sure. So these cases we're able to automatically confirm because we're able to add the fingerprints of this block page to our database. And then when it comes across similar block pages, it automatically flags them and detects them. That is why we're able to automatically confirm censorship when these block pages are detected. For all the other cases of censorship, like DNS, TCP, and so on, those cases are not currently been flagged automatically, although we are getting closer to that point as we improve our heuristics on an ongoing basis. But for now, we definitely advise speaking to an engineer or reaching out to the OONI team if you have doubts about interpreting an anomalous measurement. So the OONI Explorer interface that I mentioned before, it has a search tool, a powerful search tool for exploring the measurements that are published every day. And actually, not even every day, every minute, because now we have a new fast-path data processing pipeline that literally publishes measurements from around the world in near real time, literally within a few minutes. And so what you can do, so as soon as you run a test, you can go there and expect to find the relevant measurements. With a search tool specifically, you can filter it based on the country that you're interested in, based on the OONI probe test that you care about, but also based on ASN. By ASN, we mean basically the sort of identifier for the network on which it is run. So say, for example, you are in Italy and you're interested in measurements you're interested in measurements from Vodafone Italia. Then all you can do is Google search Vodafone Italia ASN. You will get a number, add that number in the ASN, and then filter the measurements accordingly. But for me, one of the most exciting features of the search tool is that you can also filter based on anomalies and confirmed blocked. So that allows you to very easily gain access to the most recently blocked websites in a country. This is very exciting. However, it does have its caveats, which is that it obviously depends on which websites were tested. So for example, if there are blocked websites but they're not being tested, then they won't show up. But it also depends on whether we have already added the fingerprint of those block pages to our database and updated our database in order for that to appear in OONI Explorer. So for example, if we've missed some block pages, then they will not be automatically detected and it will not automatically appear here in this interface. So if you do come across block pages, we encourage you to reach out and to share them with us. You can either do that on GitHub, or you can do that by interacting with us on IRC or Slack. If you're interested in downloading the raw measurements, we provide the OONI measurements in JSON format, and you can download them from the OONI API. However, we recommend using the OONI API for lightweight queries because other tools such as OONI Explorer rely on the OONI API. This means that if you use the API to download, for example, all of the measurements ever collected from India or some other place, there's the risk that will make OONI Explorer less performant, and then people won't be able to use an Explorer and it'll make us sad. So please do not use OONI API for heavy querying. Please just use it for light queries. If you are interested in doing batch data analysis, and we definitely encourage you to do so, we have two alternative solutions for that. On the one hand, there is the OONI PostgreSQL MetaDB, which is essentially the same measurement database that powers OONI Explorer and the API. So the same thing that feeds measurements into OONI Explorer and API, you can have the exact same thing for yourself, and you can configure it to get the measurements that you care about. Isn't that cool? And so there are various projects that already make use of this, and they use this in order to integrate OONI measurements into their projects. An example of this is the Berkman Klein Center at Harvard University. For their Internet Monitor project, they use the OONI PostgreSQL MetaDB to insert relevant OONI measurements into that. And quite similarly, also Cython for their public dashboard engine, they also integrate OONI measurements for that. Alternatively, you can fetch OONI measurements from Amazon S3 buckets, and they also provide tooling which makes big data analysis much easier. So if you're interested in this, from the link that I share on the data section of our website, you can find further links which provide guides and step-by-step instructions on how to do this. And also in the FAQ section of our website, we also provide further links and guidance. So why do we publish all measurements? Why do we have this insistence on open data and publishing all the measurements? Well, for starters, to increase, as mentioned, to increase transparency of internet censorship and to support public debate and provide evidence of internet censorship. And the reason why we say that these measurements can potentially serve as evidence is because they clearly show which internet service provider blocked access to a specific tested website or a specific app, and it shows which censorship techniques they adopted in doing so, which can actually serve as evidence that in fact did happen. And we definitely want to move more in this direction instead of just relying on empirical evidence, which cannot always be necessarily accurate, especially since confirming censorship can actually be very tricky. Furthermore, we hope to support reproducible research. We hope to enable researchers around the world, to conduct their own independent studies through OONI data and explore research questions that they care about. The OONI database is so vast. There are so many measurements from all around the world. It is literally a gold mine waiting to be explored by data analysts and researchers out there. There are so many cases of internet censorship that we're probably sitting on and we probably aren't even aware of. And by making the database open, we hope that you can work with that. Finally, and more importantly, we hope that when we publish research reports based on OONI data analysis, that you can go and verify our claims. We don't want you to blindly trust us that what we are saying is accurate. Instead, we want you to question our claims and to check whether what we're saying is accurate based on open data. And finally, by openly publishing all the measurements, we hope to sort of archive the internet in a way, or archive network measurement data, because by having all these measurements, by having these millions of measurements from more than 200 countries, going all the way back to 2012 published, you can go back in time and see what was happening in different countries around the world and potentially correlate that with events, and therefore have a deeper understanding of how the internet evolved and how network interference and internet censorship was implemented. And more importantly, it can help us explore and evaluate how censorship and how information controls change and evolve over time through this database. And so we hope that you will join us in running OONI in order to help us archive part of the internet and document what is happening on this space that we live on, basically. So I've been informed that I'm seeing now that actually there's not much time left, unfortunately. So I'm going to open it to questions and answers. But before I do, I guess just very quickly, we've published many research reports covering many cases of internet censorship around the world in collaboration with our great partners. These cases are based on openly available OONI data. I encourage you to go to the reports section of our website to read our research and to learn about these cases. Many of these cases are politically motivated. If there's one thing that stands out through OONI data is that we tend to see an emergence and a spike of censorship events leading up to and during political events such as protests and elections. And I think this signals that it is therefore very important to monitor networks and to measure networks on an ongoing basis so that when and if these cases occur, we are ready and we have relevant measurement data to use as part of advocacy. We have also come across many cases of media censorship. I guess one example that is definitely worth mentioning here is a recent case in Myanmar about how they blocked fake news websites, or rather they blocked websites that are considered to be fake news or deemed to be fake news around basically spreading false information around COVID-19. However, the official block list was not disclosed, but by analyzing OONI measurements, we found more than 40 media websites to be blocked, many of which are ethnic media websites based in Rakhine and reporting on the region. We have also, through OONI data, come across the blocking of minority group websites around the world, such as the blocking of LGBTQI websites, the blocking of ethnic minority websites, and also the blocking of religious group websites. And as mentioned, I think one of the most interesting things is that you can observe censorship changes through OONI data because it spans over a long period of time. So that being said, and given that we're running out of time, are there any questions? Oh, thank you for that. So we have one question from Chris, which, yes, I will read the question. Thank you, Chris, for your great question. The question is, have you tried to categorize the severity of censorship across countries? That is an excellent question, and thank you for that. I guess the answer is not really, and that is sort of intentional, in the sense that, well, yes and no. Yes, in the sense that we try to document as many cases of censorship as we come across by analyzing relevant measurements, and we usually discuss them openly, and then through these published reports you can probably do a comparison and evaluate. But no, because we feel that censorship is very contextual, and we feel that it may not necessarily be fair to compare censorship across different countries which have different laws, different regulations, and there are different circumstances that led to the censorship event occurring. So in that sense, we tend to refrain from openly comparing countries because we feel that it will likely be inaccurate. That said, we do discuss the censorship techniques been adopted, and we try to we do have discussions around which countries have, for example, more sophisticated censorship techniques, which countries block access to more websites, and so on. But again, I feel like the analysis has a lot of limitations because it depends on which websites were tested, it depends on the measurement coverage, like how many measurements were collected from that country, how many measurements were collected in each network. So if we had equal measurement coverage across countries, and if the same websites and the same apps were constantly being tested, if we had an equal ground of comparison, I think it would be easier to make that comparison. But since we don't, I feel that yeah. But that being said, also I think that said, I think you're more than encouraged. You're welcome to do that comparison as part of your research if you feel that that's something you'd like to do, and we're definitely very curious and learning about the methodology that you will adopt, and maybe we can learn from you and integrate some of that into OONI Explorer or into one of our platforms. I hope that answers the question. Is there a way of knowing if I didn't answer it extensively, please feel free to ping me later. I can discuss further. So we have another question from Ramakrishna, which asks, do you account for stateful blocking in your web connectivity tests? If so, which countries and networks do you commonly see this behavior? Stateful blocking.
Okay. I guess I can answer this.
What do you mean by stateful blocking in this case?
I think wait, I can since we're here.
Hi, there's also my colleagues here.
Hello. Hello, I'm Arturo. I also work on OONI. So yeah, I guess the question is. So let me just repeat it a second. So where did it go? Oops. Here we go. So, do you account for stateful blocking in your web connectivity tests? If so, which countries or networks do you commonly see this behavior? So, I suppose what you mean by stateful blocking is like if there are certain countries or certain networks that, depending on certain network activity that the user is doing, they will change their filters and adapt it to behave differently. So, whether that is because they notice that you're accessing a lot of blocked content and they decide at that point to put you on some sort of special list by which they will then treat your network traffic differently. Our web connectivity tests do not take this into account, at least not in the current analysis that we are doing. I've heard rumors of this happening in places like China, where there are some components of the Great Firewall that appear to be stateful. But yeah, it's definitely a thing that we should be taking into account, at least in the analysis stage. But it has not in the work that we've done so far. It's not been so prevalent to warrant any extensive work or research or implementation of some workarounds for that. So I hope that answers your question.
Great. And so for the final question, which is from Anadas, Regarding light or heavy API usage, a disclaimer on what light-heavy means may be useful to newcomers of OONI data analysis. Thank you. That is an excellent point. We should definitely take note of that, and we should definitely edit the page of the API in order to maybe include a link to another section of the website which explains this, or to explain it directly there on the API. But you're right, we should definitely elaborate what we mean by this and maybe provide examples. Did you perhaps have any thoughts on how you would like us to go about it? Or is what I'm suggesting reasonable?
There's also some lag in the video, so it will take them some... We can maybe read some of the comments that people are saying while we wait for Vasilis to acknowledge. So, like...
Sorry, I can't read that. It's very small. So, John Camfield says, I seem to recall Iran was also doing this, interrupting encrypted channels, but only after 60 seconds. Thank you, yes.
And David also mentioned...
Moses is mentioning, I trained some folks in my country on how to use OONI. Thank you, Moses. That's very exciting. Thank you for your community engagement efforts. Sorry, which other one were you referring to?
David from IRC is saying that he thinks he once uncovered stateful blocking from OONI data. Can't find the analysis now. It manifested as about a dozen random sites being blocked in each test run from each probe site. It would be very interesting if you manage to find it and you can share it. It would be really interesting to take a look at that.
Yeah, thank you, David. I think any cases that you come across as part of your research analysis, if you can share them with everyone else as well, like on the OONI channel here on IRC or Slack, I think that would be greatly appreciated so that we can learn from each other. Are there other questions? Okay, so it seems that we're out of time. Let me just move the slide here. So I guess in summary, if you want to get involved and participate in the OONI community, some of the things that you can do is that you can run OONI probe to contribute measurements. Any country that you're from, I think measurements from everywhere are helpful and useful, especially since censorship events change, often in correlation to political events as they change. So please run OONI probe. We'd also appreciate contributions to the test list so that you can inform which websites are tested by OONI probe users around the world. If you'd like to help with translation, that would also be very much appreciated. That is coordinated by the localization lab on Transifex. If you analyze OONI data and come across interesting cases like the one that David just shared, I think it will be very much appreciated if you can share that with the community. And of course, we encourage you to participate in discussions. We also have monthly community meetings. So I guess that's it. And if you have further questions, please feel encouraged to reach out to me or my team. You can reach us via email, but also, You can reach us via email or directly on Slack, on IRC. There are many channels that you can reach us. Please reach out with anything you may need. And thank you so much for your time today and for your patience and for your questions. And stay safe. And thanks for joining us today, and hope to see you in the next sessions over the next days. Tomorrow we have a session on test list by Igor, as mentioned, at 3 p.m. UTC. And then we have sessions every day next week. They're going to be super exciting, including projects like MLab, RIPE, and many others. So hope to see you there. Thank you for joining us today, and hope you have a great day or evening, depending on where in the world you are. Thank you. Bye.